Hello everyone, my name is Javier Ortiz. I am your mentor throughout this program and welcome to this webinar. So brief reminders before we start. As always, remember that our study group resides here in Slack in the DEND session 963. Each week on Tuesdays, I post a weekly roundup where I share all the lessons that are doing that week and any scheduled events such as this one with the link to access the webinar, my Calendly link to schedule one-on-one meetings with me, and any projects that we have due. All right. And with that being said, this week you should, if you are progressing along the suggested schedule, we should be finishing all the different lessons in data lakes with Spark, Power Spark, Data Wrangling with Spark, and debugging optimization, such that on this next Tuesday, you'll be ready to start the new project, which is Data Lakes with Spark. And you should have like 2 good weeks to work on that project if you follow this suggested schedule. All right, so today's webinar will be focusing on data wrangling with Spark. All right, so hopefully you already progressed through the first lessons about Spark, and so that you'll be ready to tackle today's topic of data wrangling. Okay, so we know many things about Spark, about how it's basically a model to work with distributed systems, and which makes it great for ETL, makes it great for machine learning, to work with big data. And today I want to focus on 3 main things that you can do with Spark. And the first thing is, and all of them are regarding data wrangling. The first thing is about maps and lambda functions. The second thing is how to read and write data into Spark session. And finally, data wrangling with data frames, all right? And so let's get started. Okay, so maps. As we can read here, maps take data as an input and then transform that data with whatever function you put in the map. So basically, you take this data, and once you use the map function, whatever function you put inside the map, you're going to apply that to each and every data point of that you fit it with, right? And so it's really, really straightforward, and we're going to go over this example. All right, so we're importing PySpark over here, and we're creating a Spark context object, which basically allows us to work in a distributed system. And what we're going to do, we're going to take a Python list, and this Python list, once we use the SC, well, this is the object, the Spark context object, the parallelize function on it is going to create same list, but ready to be worked on a distributed system. All right, so let's run that. All right, and here we are. Okay, now this one is a regular Python function. We have the def, we have the name, which tells us it is a function, the name of our function, the input that the function is going to take, in this case is going to be a sum, and finally our return statement, which is going to take that sum that we fitted in the input, and it's going to make it lowercase, and we're going to return that sum in lowercase, right? And here we use it, convert sum to lowercase, we feed it with a sum, and it should give us sum in lowercase, and it does. All right. Now this part demonstrates how to apply this function using a map step. So we have the list, the distributed song log, and remember that the map, what it does, it takes a function. So here's our function, and it's going to apply this function to each data point in our list, right? So to each one of this, is going to apply this function, the convert song to lowercase. And that's it. It's really straightforward. So that's what math does. Let's see it. And remember that Spark uses lazy evaluation. So it doesn't execute the map until you force it to, all right? And to actually make it run the map, what we're going to do is we're going to use the collect. The collect, what it does, it basically takes, since you are processing this in a distributed system, it collects from all the different machines the work that each machine is doing, and it shows it in the main machine. So let's do it now. And now it shows the different elements of the list that you're applying this function through the map. All right? And that's that. Okay. Now, an important thing that you can notice here is that the original data set is not changed. Spark is making a copy. And if I run collect on the original data, you can see that it hasn't changed. All right? Great. Now, moving on to lambda expressions, all right? These lambda expressions, the beginning used to be really difficult, really confusing to me, but they are really straightforward. You just have to break it down. Okay, so we're going to use the same map function. Now remember, the map function, what it does is takes a function and it applies it to each and every record here in our data. And what we're going to do, instead of defining this a different function as we did over here, what we're going to do is that we're going to define the function here inside the parenthesis, right? So the lambda basically takes this complicated function over here. I mean, it's not complicated, but it's defined as a different block, and it's really easy. So you can write it just in one line. So, and it makes it possible to write it in one line, right? Okay, so what does lambda mean? So lambda is this Greek symbol, and actually it was an accident. It wasn't supposed to be named lambda, but it was like an arrow, and the typewriter just messed up, and instead of writing the arrow, wrote the lambda Greek symbol. And so now they're named lambda. And all it does, it says, all right, this is going to be your input, all right? So song represents the input. And every time you find this variable name after the colon, basically it's telling that you're going to use the input that you're feeding here, you're going to replace it or every time it says song, all right? So here, since I'm feeding it with a list, each, and the map basically takes as an input each element of the list, where each element of the list is going to be replaced inside the song variable. That's it, all right? So I'm feeding it with the map one element at a time, and it's going to take that element and it's going to be exchanged by song. It's going to represent the song variable, and we're going to apply the dot lower function to it. And that's it. And when we do the dot collect, it's going to show the results to us, all right? And here we can see that it does. Now this name song, it can be any name that you like. For example, here we have the X. So basically anything you have after the lambda and before the colon, what it tells us is that this represents the input that you're feeding the function with. So for example, and since I'm doing this songlog.map, I'm feeding it with each element of the list. Those are going to be replaced instead of the X, right? It's all that it's telling us. And so once we have our function, this input is going to be exchanged over here. And that's it. During the lessons, the teacher suggested that you should use more describing names instead of X, which is really common. But you feel free to use other variables that can be more descriptive. All right. So that's maps and lambda functions. That being said, let's move on to read and write data into Spark data frames. All right. So as you know, data frames is a sort of data type that basically works as a Excel table, but with asteroids. That's one good way to say it. And it's usually from pandas, which is a Python library, and it has certain functionality that it's really useful for data wrangling. Okay, so what we're going to do over here, we're going to import PySpark, which is Spark with some Python that works with Python. We're going to import the Spark conf and the Spark session to initiate a session. All right. So the way you initiate a session with the Spark is you use the Spark session.builder.app name. Here you can define the name of your app. And finally, we have the get or create, which give us the option that if we already have a session initiated, we can update the name or we can create it for the first time. All right. So let me run that. And let's wait it out. And there we go, we have it. And now we can use this Spark object and apply the Spark context to get the context of this object, get conf to get a configuration, and we want to get all of the configuration, all right? And as we can see, we have here our first Python Spark SQL example, which is the name that we gave it over here. All right, and here we just are running the Spark object, and it tells about the version and the app name. All right, now let's move on. Here we have a path, all right? Basically, it's a path inside your computer. If you're working with this distributed system, all of the machines need to have access to the file path, all right? So if you only have it in one computer, that is not going to work. You need to have it available for each and every machine inside your distributed system, right? So that's why we use sometimes AWS, the S3, or you need to have it installed in each machine, that whatever data you're working on. Okay, so this file path, since I'm working just with one machine, I can find it over here. As you can see, I have a data folder. Inside the data folder, I have the Spark file, log, small, JSON, and CSV. You won't find these two. I have them because I have already run these files. All right, let's move on. It was this one. Okay. Now I have this file, and I'm going to use this file path, all right, to read the JSON file inside of it, right? So I'm taking the path. I have data, Spark file, log, small, JSON. I'm taking that path. I'm reading the JSON file that it's in it, right? And I'm basically putting it inside this user log variable. So you will have those two files. I was mistaken. I think the one you won't find is the CSV one, but the JSON you should find it. All right. Now that we have that, all right. Now that we have found that, we're going to print the schema, right? So let me open the JSON file real quickly so that you can see how it is organized. As you can see, each record is inside these brackets, and we have the same column names. So it's like a dictionary. We have the column names in a column, and then the value the column name, the column, and the value. And we have it row by row by row of data. All right. So what we're going to do, what we're doing is going to read it, this print schema, and it organizes the columns that we have alphabetically, and it tells us the data type that each column holds, right? And when we and then we're going to go over several functions that you can use to wrangle these data. Okay. Now this, it can be seen as a schema because we already read it into a data frame. Cool. So the describe function, what it does, this user log is our data frame, by the way, which we read over here. Okay, it gives us a summary of everything, all right? So it tells us like, the artist is this data type, and each of those columns, what sort of data type is it, okay? The shows us the first record or the number of records you tell it to show it to you. So for example, we have here the artist, auth, first name, gender, and session. And here we have the values that are held inside the top one row. Okay. If we do the dot take, it basically is the same. And we're showing here the first 5 rows, as we can see here. Artist, we'll show here basically all the data for the first row, second row, third row, fourth row, and fifth row. This one that shows a little bit cleaner. Okay, now what we're going to do, we're going to define the out path. The out path, what we're going to do is we're specifying the folder and the name of the file that we want to use for when we write this data, all right? And we're using the user log, which is our data frame. We're going to write and save it, and we're going to save this user log here in the out path. So inside the data folder, using this name as for the file. The format is going to be CSV. So what we're doing, we're changing it from JSON to CSV. And header true basically allows us to maintain our columns. So if I run, I'm going to get an error because I already have that file created, right? But since you don't have it, you can run it safely. All right, let's move on. Now we have user log 2. This is going to be another data frame object, and I'm going to read the CSV that we just created. And here is the path where that CSV is located, which is inside the data folder and the name of the file. And header true allows us to keep the columns. We're going to read it. Oh, I didn't run this one. Sorry. All right. That's the error that I wanted to see. And now I should be able to read it. All right, great. And we can use the same functions. The print schema allows us to see all the columns with different data types. The take two will give us the first top 2 rows. You can also use the select, which basically shows you a different data frame according to whatever you put here. So it's going to show us from user log 2 just the user ID column, right? And we need to tell it to show it to us. So this is the entire data frame. Well, it's only showing the top 20 rows, but just of the user ID column. All right. And the user log 2.take1 show us the first row, and that is that. All right. So this is how you read and write data with Spark. And we're using data frames because they are really easy to wrangle data on. And once you have finished your data wrangling efforts, you can save it like into a CSV file so you can read it again later. And that's that. Great. Let's move on to data wrangling with Spark, like the main data wrangling efforts that we can do with Spark. So as you can see, we can use we're going to import many functions from all these libraries. We have the Spark session, UDF, string type, integer type, desc, ASC, and fsum, datetime, numpy, pandas, matplotlib, sorry, and pyplot from the matplotlib library. Okay, once again, we are starting a session, right? And we are naming our app Wrangling Data. Okay, here we're defining the path, which is inside our data folder, and the file we're working on is a Sparkify logsmall.json, and we're going to read that file into this user log, which is a data frame object. And we do that, and that's it. All right. Now, data exploration, which is the first part of our data wrangling efforts. This shows you the first 5 rows for you to really start to understand your data, the different columns that you have, what sort of data each column is holding. The print schema, really useful for you to understand the columns. All right, now let's go to describe. So what describe does basically give us some statistics of each column. So that's why it's taking a little bit. So as you can see, it gives us the count for each column, how many values it has. It gives us the mean for each column, the standard deviation for each column, and all sorts of data. So this might be useful for some numeric columns, from some columns that hold this sort of data. For example, this artist one is filled with strings. So apart from count, this mean and standard deviation really don't matter. But if we use it for some numeric columns like session ID, we can understand like, all right, so our ID started with 9, and the max number that we're finding in the session ID is 7,144. All right. And as you can see, we established that we just wanted to describe one specific column from our data frame. What we're going to do here is going to count all the rows that we have in this data frame, and we have 10,000. Okay, so this one takes our data frame and is going to create another data frame from it that just show us the page column. It's going to drop the duplicates, so it's just going to show us unique values for this column, and it's going to sort it by page, which basically shows it alphabetically. And then we're going to show it. And it's loading. And here we go, here we have it. So these are the different pages that reside in our app. Great. Now, once again, we have the select, which returns another data frame with just these columns that we select over here. So this, instead of giving us all the columns that we had over here, is just going to return the user ID, the first name, the page, and the sum. And we can establish this condition where the user log, this is the same data frame we're using, where the user ID is equal to 1046. So we want to look at a data frame filled with everything this user has done regarding his first name, the pages he has been, it has access, this person has accessed, and the songs this person has listened to. And here we have it. These are all the rows where the user ID matches. The name of that person is Kenneth, and the pages this person has visited are the following. So next song is basically is when you have a playlist, you are inside next song, which means that you're going to play another song. Here it's inside home. then next song, then they log out, and these are all the songs that this person has listened to. Okay, now let's move on to statistics. All right, we have this cool feature which is the UDF, which is user-defined functions. And so when you want to define a function, you can use the UDF. Now we're going to, this function, we're going to put it inside the get hour, right? And it says the following, lambda x. So basically says whatever input you feed me, okay, is going to be represented here with the x, right? Now from the date time, we're going to use a date time, and we're going to use a from times temp, right? Which basically takes the timestamp, right? And what we're going to do, we're going to, the data you feed it with, you're going to divide it, use a here in the x, and divide it by 1,000, right? And then we're going to get the, we're going to convert that to timestamp, we're going to get the hour from it, okay? So, and that function, we're going to put it here in get hour. So basically you fit it, you fit some input to it, and it gives you the hour from it. Here's a data frame. With column, basically creates a column, and the column is going to be called hour. And what we're going to do is we're going to use our get hour function that we define over here, and we're going to take the data frame, and from the data frame, we're going to take the column TS. So for each value of the column TS, we are going to apply the get hour function to get the hour from each row inside this column. And we're going to put it here in this new column called hour for each row of our data frame. And just to make sure that we write it inside our data frame, that's why we're putting this into the user log. So let me run it, and let's see if it shows. And the dot head basically shows you the top rows, and we should find our column over here, right? And we got that from this TS, right? Which is the shows the time. All right, now songs in hour. What we're going to do, we're going to use a data frame, and we're going to filter, right? So that's a condition. So we want our user log, the data frame, the column page, we want it to be equal to next song, right? So just taking the records that the page equals next song. And we're going to group by user log that hour, all right? So we're going to group it by hour. So we'll have results for 0, 1, 2, 3, 4, 5. And we want to count how many rows where page is next song, right, are there for each hour, which is our group by. And then we're going to order them by the hour, and then the cast float. So we're going to convert that into float, because as you remember, the hour is just a sort of a time data type. But since we have it in float, it's going to order it by 0, 1, 2, 3, 4, 5. Ascending order, which is the default. And we run that, we show it, and that's it. As you can see, we have different hours as a float, and the number of rows that match that specific hour, right? So all we can learn from here is that at 0, which I guess is 12 a.m. We have this amount of listenings, and it seems that our top hour is 4 o'clock, and the hour where people listen to less songs is at 5 in the morning, I want to say. 10 a.m. It seems that 10 a.m. is the winner. All right, let's move on. Songs in hour pandas. All right, so this takes our data frame, songs in hour, which is this data frame. and it converts it into a pandas data frame. Okay, and with that pandas data frame, we're selecting the hour column, which is this first column, and basically what we're doing, we are converting that into a sort of float. Okay, so let me run that. All right, so we're creating a scatter plot, and we're taking songs in our PD, right? And we're selecting from it the hour column, and we're selecting the count column. So it's going to put one in one axis and the other one in the other axis. And here what we're doing is we're establishing a limit for the x-axis that goes from -1 all the way to 24, and y limit we're establishing from 0 all the way to the max count, right? And here we establish a label for the x-axis, which is hour, and a label for the songs play, which is the y-axis. And run again. Cool. So it's easier to see the times where we're listening to more songs and the times where we listen to less songs. Drop rows with missing values. All right. So we have what we're going to do. We're taking the data frame and we're dropping every missing rows with missing values, and especially the ones that doesn't have a user ID or a session ID. We do that. We put that data into our user log ballot, and then we count how many records we have, and we have 10,000. And then here I have another data frame where we're selecting just this column. We're going to drop any duplicates, so it's going to return just unique values for user ID, and we're going to sort it by user ID. And now this time what I want to do is we want to take the user log ballot, which is the first one, where we already dropped the ones that didn't have any values, and we're going to filter it by the user log ballot user ID. So basically, if it doesn't equals empty string, we are going to return it. And now we show it again, and we did lose some values because we had some duplicated users IDs. All right. So this one basically shows a specific example of how you can use data wrangling for this Sparkify startup. And we're taking this data frame and we're filtering it where page equals submit downgrade. So we want to show which rows have downgraded from paid subscription to free subscription. And it shows this one, right? And we're going to take the data frame and we're going to select user ID, first name, page, level, and song. And where the user ID is 138, which is the one that we found over here that submitted downgrade. And it shows all the rows where this match. All right, so we want to look at it like at what moment that this person decided to submit the downgrade. And as you can see here, this person visited this page and then it was level 3. All right, and now we want to flag downgrade event, and we're going to create a specific function for it. So whatever we feed this function with, we're going to write a 1 if the value of that input is equal to submit downgrade, and else we're going to write a 0, right? And it's going to be an integer type. So we take our data frame and we're going to create a new column which is downgraded, and we're going to use our function and we're going to feed it with everything that is inside page. Now we show it right here, and here we have the downgrade which shows 0. All right, And here we have the import window where we can partition by user ID. We can order it by time descending, and here we have the data frame, and we're going to create a column called face, which sums the downgraded column. And here's we're selecting the different columns of that data frame where the user ID is 1138, and we're going to sort it by time. This one takes a little longer. And here we have it. It's sorted by time. It shows us the phase, right? So this is when it was phase 1, and then it shows us when it changes to phase 0. And that is that. So these are some examples of what you can do with data wrangling with Spark. You have basically two options for data wrangling with Spark. You can use data frames, which is my preferred option, but you can also use SQL. It depends which do you feel more confident with. So if you're more used to working with pandas, pandas library and NumPy, I mean, go with data frames. But if you're used to working more with SQL queries, then you can go that route as well. So that's all the time we have available for this webinar. Hopefully you learned something or some questions, some doubts were cleared. And don't hesitate to ask for help through the Slack channel or study group, and or schedule a one-on-one meeting with me through the Calendly link, also available in the student group. Right? So have a great weekend, have a great learning week, and don't forget to keep progressing with the lessons and start working on the next project anytime during next week. All right? Have a good one. Bye.